Pythagoras' theorem helps us to find the length of an unknown side if we're given any other two sides. So let's just start by labelling the triangle. That tells us it's a right angle. This is side A, side B, side C. So they'll have different lengths. The longest side on a right angled triangle is always the hypotenuse. And what Pythagoras very cleverly did was he discovered that we can calculate the length of side A, the hypotenuse, by taking the square root of the sum of the other two sides squared. So that is b squared plus c squared. You need to watch what you do with your calculator on this. Make sure you take the square root of all of this and square the individual parts. Okay, this is used a great deal in electrical work, but a very common triangle that you will use on site is the 3, 4, 5 triangle. So 3, 4, if I wanted to calculate the length of this, I know that once this is 3 and this is 4, the hypotenuse is 5 because I've used it so many times. We can use Pythagoras. Let's call this the hypotenuse. H equals the square root of 3 squared plus 4 squared, and it's the square root of all of that. So that is the square root of 3 squared is 9 plus 4 squared is 16. The square root of 25 is 5. So this is a 3, 4, 5 triangle. Importantly, it works if it's 30, 40, 50, 300, 400, 500, 3,000, 4,000, 5,000, and so it goes on. This is really useful on site. You can get 3 scraps of wood, say 3 feet long, 4 feet long and 5 feet long, and as long as you screw them together accurately, you will produce a right angle. And if you're stuck on a distant or remote site, that is a very handy way of ensuring that you're, for example, installing conduit at a right angle and getting things correct. So let's move on and look at the examples which appear on your handout. So example 1, in the triangle shown below, if B is 15 meters and C is 25 meters, how long is the hypotenuse? Well, here is the hypotenuse, 15 and 25. So write down the formula. The hypotenuse equals the square root of 15 squared plus 25 squared. And if you put that into your calculator, that'll come out to 29.2. Okay, so that was example 1. Let's quickly move on and look at the other examples on your handout. So, sorry, I've missed a bit there. So, example 2, if you read the question, it says that x is 170, r is 250, find the value of z. I've chosen these letters deliberately because it introduces a really important electrical formula. So z equals the square root of r squared plus x squared. If we put the numbers in, it's the square root of 250 squared plus 170 squared. And if you put that into your calculator, you should come out with 302. These are all in ohms. Just a quick check. the hypotenuse must be longer than any of the other two sides, 170, 250, and this is 302. So a reasonable effort. Let's do the last example. In the question, or the example on your handout, this says that Z is 200, R is 180, and we have to find X. You have to transpose the formula now, and you start from Z equals the square root of R squared plus X squared. And if you transpose it, you will find X is the square root of Z squared minus R squared. We'll come back to that in just a moment. If we put the numbers in that we have, the square root of 200 squared minus R is 180 squared. Put it in your calculator, 87.2 ohms. Okay, really quick recap of these two examples. If you are finding the longest side, then we have plus in the formula. So we're going to square each one of these and add them. If we're looking at finding one of the shorter sides and you're given the longest side, the longest side comes first, and then we subtract the smaller side. So finding the long side, that is plus. Finding one of the smaller sides, that is minus. And you must start with the biggest number first, or else you'll get a syntax error in your calculator.